All right, baseball's popped up, lands on a light tower that's 23.8 meters above the elevation of the bat after having been in the air for 4.75 seconds. So let's draw a little picture of this. Here's the ground. Here's a light tower. Got some lights there. The ball goes up. Right, and then it comes down. So how does it do that, right? It must move over a little bit, right? It's a question. Or the light tower scampers in underneath the ball, right? So presumably it goes above the tower and lands on it, but we'll be able to figure out which one happened. And this light tower is 23.8 meters above the ground. Ta-da. Right? And so I think what we can do is we can solve A and B together. So let's do that. Let's go X, VI, VF, A and T. I think our net displacement, our net change in position from here to here is positive 23.8. Now the distance is bigger than that, but we don't deal with distance. We deal with net change in position. Our initial velocity is we don't know. Final is we don't know. How can it be solved? Right? And then this is negative 9.8, and then this is 4.75 seconds. Okay. I think the only way to get into this is to use the formula X is VIT plus 1/2 AT squared. Okay, so 23.8 equals VI times 4.75 plus 1/2 negative 9.8 times 4.75 squared. Holy cow. Now what I'm going to do, this thing here is going to be negative, right? I'm going to bust this guy out and I'm going to add it to 23.8, right? That'll get it off this side, right? So I'm going 0.5 times negative 9.8 times 4.75 squared. That's negative 110.55, right? Okay, and then I'm going to go, I'm going to subtract that from the negative, right, from 23.8. And I get this side here is 134.35625 equals VI times 4.75. Okay, so you see what I did? I busted this whole thing out, and then I added it to both sides. So I put it on this side here. Since it's negative, you end up adding a or subtracting a negative, which is adding it to this side. And now all I have to do is divide by 4.75. And I get 28.2855. So VI 28.2855 meters per second, right? And that is actually a positive, a strong positive, as we know that it's a positive value, right? So there's the initial velocity, right? And then let's figure out the final velocity. To do that, I'm going to use, let's just cut out a little space here, right? I'm going to use VF is VI plus AT, right? And so the final velocity equals the initial, so positive 28.2855 plus negative 9.8 times 4.75. Okay, so I'm going to go that minus 9.8 times 4.75. Negative 18.26. Ta-da! And there's this guy, right? So that's the velocity. It strikes the tower. It's going down, right? So we answered the question, did it hit it on the way up or the way down? It hits it definitely on the way down. Definitely leaves the ground going faster. These are all things that make sense, right? And then what's the greatest height the ball reaches? Well, to do that, we're going to have to go from here to here, right? So x, vi, vf, a and t. At the top, the final velocity is 0. The initial velocity we'll use is this, right? So positive 28.2855. And then the acceleration is negative 9.8. Okay? And then to solve that, we're going to use, I think my favorite for solving that would be vf squared is vi squared plus 2ax, right? So we know this and this and this. We can solve for the x, right? So 28.2855 squared and then divided by 2 divided by 9.8 is what it'll end up being. 40.8, so about 41 meters. 41 meters is the greatest height. Okay? Hope that helps.